Hello, my name is Professor Johnson, and today I will demonstrate a Venn diagram example for you. So, a survey of 100 adults found that 78 like peanut butter and banana, 80 like peanut butter, 88 like banana, and below will be the summarized data. Now, I've covered up the data so that we could practice filling in the numbers here. So, when you see that 78 like peanut butter and banana, the AND statement goes in the intersection. So you see how peanut butter and banana intersect in the middle here? So that's going with the AND statement. So I am going to put a 78 right in the middle there, okay? So we have placed a 78 in the intersection. I've done that so far. Okay, now look at this next part, 80 like peanut butter. Well, in the peanut butter circle, that would enclose all of this, right? If I just circle this whole thing. So over here, I need to look at these two numbers to give you 80 total. So we have 78 right now, but you need to add 78 plus something to give you 80. Well, we could probably easily count in our head 79, 80, right? 2 brings you to that. So now we have 80 total in the peanut butter circle, right? In this circle, this enclosed the 80 adults that like peanut butter from this made-up example, okay? Now, 88 like banana. So something similar occurs over in this banana circle. So 88 would be over here. Now, what we know is that 78 is in the intersection. Well, how many are just in the outer portion, just liking only banana, not banana and peanut butter? Well, we would have to add 10 to that to get to 88. 78 plus 10 gives you 88. So 10 and 78 bring you to 88 in that banana circle. So then we could see that we've completed that. But now we need to consider that we have 100 adults total. And right now, we have only accounted for 2 plus 78 plus 10. So far, we've only accounted for 90, but we need 100 total. Well, so 10 would go out in the outer box. And now we have accounted for all 100 adults in the data set. Just that 90 of them landed in the peanut butter banana mess in the middle. Okay, so now that we have that, we have our Venn diagram completely filled out. Let's look at some probabilities. Now, probability will always be a value between 0 and 1. So let's find the probability that a randomly selected person likes peanut butter. So let's look at peanut butter. If I go to the peanut butter area, we have found that 80 total like peanut butter out of all 100 people. So it's 80 out of 100. Now 80 out of 100, I could do this in my head simplifying, but if you want to use your calculator, you could get 0.8. So it is a value between 0 and 1. But what I want to show you is using the math button, hit number 1, it chooses fraction, you can hit enter, and you get 4/5. So 4/5 would be our simplified fraction. That'll be our probability. So that would be just liking peanut butter. This also makes sense because if it likes peanut butter, we were told 80 like peanut butter. So 80 out of 100 like peanut butter. That also checks our answer from the beginning. Okay, number 2. Find the probability that a randomly selected person does not like banana. So does not like banana. Well, if we look at the banana, these 88 like banana. So everything outside of it, right, if I just cover this up, everything on the outside is not banana, right? Not banana. That would be going with the 2 and the 10. Does not like banana. Well, there's 12 of those people that do not like banana, right? They're on the outer reaches, right? These 2 over on the right only like peanut butter, only. Those 10 don't like peanut butter or banana. So there's 12 total out of all 100 that were surveyed, so 12 out of 100, right? That's 0.12. But if we want the simplified fraction, we could say that this is 3 out of 25. Okay, so there's our probability. Going on to the next one, number 3. Let me erase all of the scribbles so that we have a blank slate. So given that a randomly selected person likes peanut butter, so we're given something. Let's highlight that in blue. Given that they like peanut butter. So let's highlight that. So liking peanut butter would be this region. Okay. When you have a given statement, this is a special statement. It's what's known as a conditional probability. We will only look at what is given. So we're given that they like peanut butter. We're only looking at those students because we don't care if they like banana or don't like banana, right? We just want to look at the peanut butter people. So we're only going to look at those 80 peanut butter people. So that becomes my new denominator when you have a given statement. So we're only looking at those 80 peanut butter people. Now, of those 80, what is the probability that the person also likes banana? Well, that person would be in that overlap, right? That would be the 78 that like both peanut butter and banana. So 78 out of 80 would be the probability here. So 78 divided by 80. I can simplify that to 39 out of 40 would be my simplified fraction. So let me recap that. Given that a randomly selected person likes peanut butter, what is the probability that the person also likes banana? With a given statement, you only go to what's given. You only go to what's given. I'm going to cover up everything else because you only care about who or what situation was given to you. And then of those people, now the probability of liking banana, well, banana only overplays in that 78 value. So then simplifying, you'd get 39 out of 40. Okay, so let me erase all my scribbles so we can start a new one. What is the probability that a randomly selected person does not like banana? So does not like banana. Let me use a different color. So does not like banana, given that the person likes peanut butter. So again, we're given that they like peanut butter. So given that the person likes peanut butter, I am only looking at this region. So that is looking at just those 80 people that like peanut butter total. What is the probability that they do not like banana? Okay, well, we know that banana would be these guys, but with the given statement, I'm ignoring those 10 values. So not banana would actually go to these two. So it would just be 2 out of 80. So 2 out of 80, and we can simplify that using our math button and fraction button. We'd have 1 out of 40. Okay. So just remember, when you have a conditional probability is these probabilities with a given statement in them. You will reduce down to what you know, right? If you know that the person that you've randomly selected likes something, only look at that group of people. And then of that group of people, they will either like banana or not. You try to keep it as simple as possible. Okay, thank you for watching my video.